Hello friends, welcome to SimulationKart. In this video, we are going to simulate the field-oriented control of induction motor with field weakening and MTPA with Indian drive cycle. So this is the source which will give us the drive cycle. The drive cycle will be in terms of meter per second. The drive cycle that we are using here is Indian drive cycle. Since the output of this drive cycle is in terms of meter per second, we are converting that to RPM and later on to radians per second. The actual speed that we get out of the motor will be in terms of radians per second. Okay. So here we are trying to implement MTPA, maximum torque per ampere, also the field weakening method. See, this field weakening method will be applied above the certain speed, above the base speed, right? So before getting into that, we should know FOC, field oriented control. See, in the field oriented control, there will be two loops. One is the outer loop and the next one is the inner loop. So this forms the outer loop or the speed loop. See, in the speed loop, we will be comparing the reference speed with the actual speed. After this comparison, the error will be generated and the generated error will be fed as input to the PID controller here. And this forms the input to the next stage, that is IQ reference. And from here, we'll get ID reference. Okay. So the IQ reference will be derived from the outer loop, that is the speed loop, whereas the ID reference, that is the direct axis current reference, will be derived from MTPA block as well as from the field oriented control, field weakening control block. Okay. So here the IQ reference will be compared with the actual IQ. This actual IQ will be derived or calculated from the phase currents IA, IB and IC. So to calculate this, we are using ABC to DQ transformation. This block refers all the three phase currents, also the theta. Okay, so this theta calculation is done from this block. So here we are converting the ID to flux, and later on by using this formula, we are finding out the theta. Okay. Right. So here we are finding out the stator current, the net stator current. This net stator current is found by using this logic. Okay. And then we are applying MTPA. See, in MTPA, we are using all the motor parameters, and later on by using the torque constant, we are finding out the value of uh, ID reference, and this ID reference is fed to the next stage. So here we are applying the field weakening method. See, this field weakening method is done based on the base speed. So initially we need to feed the base speed. So when the actual speed is below the base speed, MTPA current will be fed as ID reference, and when the actual speed goes above, or when the requirement of actual speed is above the base speed, we'll go for field weakening method. Okay. So in the case of field weakening method, the value of ID will be reduced so that the current will be so that the actual speed will go above the base speed. Okay. So we have run the model already. Since this is a drive cycle based simulation model, it will take more time. So for that reason, it is simulated already. So this is the Indian drive cycle. So in the Indian drive cycle, we have two things. One is the yellow color line represents the reference drive cycle, and the blue color one represents the actual output of the motor. So as you can see, the motor is keenly following the Indian drive cycle exactly without any deviation, and below that we can see the corresponding torque produced by the motor. And here you can see the current drawn by the motor to produce that amount of torque and speed. Okay, even you can zoom it. Okay, yes. So here you can see the ID reference as well. So these are the places where the field weakening was applied. So whenever the field weakening method is applied, you can see the value of current getting decreased. Okay, so all these are for MTPA and these are for field weakening. So thanks for watching this video. Uh, the same model is available for a download from the link given in the description. If you want, you can use it for your purpose. Thanks for watching. Kindly share our channel to your friends. Thank you.